yesterday with Alex, he wanted to put in an extra cos. This doesn't have an extra cos, we can't do it. We can't just put in times 1 and put in a cos and a cos.
Put an extra sine in.
So we've got a problem. You know what to do.
Sine times sine squared x.
I'm impressed.
Oh, that's a first.
So you can just go that sine squared x by sine x.
Yes.
You right? And what can I replace? We need a cos. In the middle of a sine we need a cos. In the middle of a cos we need a sine. So I could go hint, like, you know, hint sine squared x plus cos squared x equals 1, or use that. So I can turn the sine into 1 minus cos squared x. Don't forget the b word. What do we do that for? Finn's going to look at it and go, I don't know.
Substitution.
Expand the brackets. Maybe if I wrote there, expand.
That's the E word.
The E word. It's not the same as the B word. Anyway, sine x minus what?
Sine x cos squared.
Now, funny thing is, Finn, if no one ever showed you this, I never would have thought of it. I don't know, maybe I would have. It's not that hard to think of. You'd have to be thinking to yourself, it's got to be something to do with that. Do you know how to integrate a sine?
Negative, I mean, not negative cosine.
Yeah, it is negative cos.
Negative. So cos become, cos will give us negative sine. So negative cos. And what's this big one here?
1 plus.
No. Talk to me in principle.
We should have to find dx of the
Reverse of the
Chain.
rule. Now, this is where I like my little shortcut of just going, write the same thing down, but the cos squared's got to be cos cubed. Why? We're increasing the powers when we're integrating. So a 2 becomes 3, so you divide by 3. What else do you divide by?
Sine x.
The derivative of the inside. So I'm going to write that there in case you look at it later. Derivative of the inside. Now again, issue is like ready. Oh guys, I see everyone mess it up. Like hello. Yeah. You getting the message? Hello. You know, I'm going to go the whole hog. Don't forget. Don't forget what? The inside. And sine x is there for the right. So sine x has got to stay there. Derivative of the inside is, what's the derivative of cos?
Just sine.
What?
So cos is a minus sine, isn't it? Derivative of cos is minus sine. So when we did this, oh no, we won't go there yet. Have I got it right?
Yeah.
No mistakes? And the only reason that method works, so if anyone who's watching, they've never seen the reverse of the chain rule talked about, this is a lot of students never ever get taught that. It's just one of those things I do. Only reason it works is?
Reverse of the chain.
Only reason it works is?
The back.
The sign with the x's cross out. If they didn't cross out, now you can talk about the outside looks like it's the derivative of the inside, blah, blah, blah. So the answer's just, now I was mucking around, it's interesting to take this answer, which is plus 1/3 of cos cubed x plus c. If we differentiate it, we get back to the, I could go this, Jake, hint, ready? Sine squared 4x plus cos squared 4x equals 1. So the same principle applies. So it's yuckier. Yuckier or what? I use it all the time. You put the 12 on the outside, why? Because you can. You don't have to. You can leave it there if you want to, okay? Oh. Why would we do that? So we want to get a sine into a cos question. Or we want to get a cos into a sine question. Why? Because someone a long time ago said, here's a nice little trick. And we all do it. So, what do I write instead of that? Come on, Jake.
Okay. You go 1 minus sine squared 4x.
Yep. By cos 4x. I want to make a little note about this for a second. Then we've got to expand. Expand what?
The
Stuff, yeah, the brackets, the stuff in the integral, whatever you want to talk about.
See this, if you-
So,
which-
we still haven't done anything except for, see, and I've forgotten to write about the rearrange. Rearrange, until we can do something with it. So, 1 times that would be cos 4x, and you go, that's easy. I can get the integral of cos 4x. What's the next one? Simple, reverse of the chain rule. Simple, reverse of the chain rule. So what do we have? Now back to Jake again. Where's
Okay.
cos 4x come from?
Sine 4x over 4.
Yeah. Don't forget divide by the derivative of the inside. So is this a reverse of the chain rule?
Yes.
Yes.
Yes, and you see it like that now. So that's a sine what?
Cube.
Cube 4x. Cos is there for the ride. We don't do anything with it. Fraction. So we divide not by the 4 straight away. We're dividing by the
Now,
power. And then we divide by the derivative of the inside.
Which is
So
4.
what's the derivative of sine 4x?
4 cos.
Yeah, you could do that. Or you could, yeah, let's go it. Do you just see it as 4 cos 4x? Yeah. Or if someone doesn't, most students I found that if they're struggling, will go, well, that's cos 4x. And what do they forget to write? 4. And plus a c. And we tidy it up and the question's done.
3 sine
Finished?
4x minus sine.
Yeah,
3
tell me.
4
Come on, say it again, Alex. Clearer. Sine, 3 sine.
4x minus sine cube 4x plus c.
Yeah, because the 12s will cancel, the coses will cancel. If it don't cancel, it doesn't work. So it's just sine cubed, isn't it? 4x plus c. No mistakes?
No.
And if we differentiate that, we'll get back to there.
Hopefully.
Using that.